All right, we're back with Bohr-Rutherford diagrams. Bohr was a scientist, Rutherford was a scientist, and they are the ones who have contributed to our modern understanding of what an atom looks like. So, hence the name Bohr-Rutherford diagrams. Now, these are just a way to basically draw what an electron looks like. So, what we have here is the atom of fluorine. And fluorine, the symbol of fluorine is F. Now, going to our periodic table, we can see fluorine right here. It's one of our halogens. It has an atomic number of 9. Only fluorine has an atomic number of 9. Only fluorine has 9 protons in its nucleus. And it has a weight of 18.996, which we are going to round to 19. So, it says here the atomic number is 9, which means it has 9 protons, but it also has 9 electrons to make it neutral. The pluses and the minuses have to equal each other. And we can also do the math, and we know that it has 10 neutrons. And I'll show you this in a little video. Now, what we have here is the nucleus. And I actually don't, this is a clip art picture. I actually don't like this. It's a little bit incorrect. The true Bohr-Rutherford diagram, inside the nucleus, you should tell me how many protons and neutrons there are. So there are 9 protons. You would write that in here. And there are 10 neutrons. So you would write that in there as well. Now we know that there are 9 electrons. These lines around the nucleuses, these are called orbits. The same way that the sun or the Earth orbits and all the planets orbit the sun, electrons orbit the nucleus. So that line is just showing their path. Now, the first orbit, the first one that's closest to the nucleus, it can only hold 2 electrons. That's all it can hold. It can have 1 or 2, but maximum 2. And that's why if you look in this one, there are 2. 1 right here and 1 right here. The second orbit can hold 8. And the third orbit, if needed, can hold 8 as well. So you can see that here. 2, 8, 8. And the fourth can hold 18. So for fluorine, we know it has 9 electrons. So 2 in the first orbit. And that would mean 1, 2, 3, 4, 5, 6, 7 more in the second orbit. 2 and 7 equals 9. That's all of them. So here's aluminum. And we know that aluminum has, well, let's go to aluminum in the periodic table. Aluminum's right here. It has an atomic number of 13. That means that we have 13 protons and 13 electrons. And I'm having a hard time seeing on my computer here, but I think it has a weight of 26.982. So we would round up to 27. So it would have 13 protons, 13 electrons, and it would have 14 neutrons to get enough weight. So when we draw this up, in the nucleus here, I would want you to put 13 protons, 14 neutrons, and then we have 13 electrons. So we draw our first orbit and we put 1, 2. We draw our third or second orbit, which holds 8. So we put 8 in that orbit. Now 2 and 8 is 10. We have 3 more electrons to draw. So we draw a third orbit, and there's our 1, 2, 3. If you were to count all the electrons, there would be 13 in total. 2 in the first orbit, 2 out of 2 in the first orbit, 8 out of 8 in the second orbit, and 3 out of a possible 8 in the third orbit. That's that. I will do a little YouTube video, draw a few of these up for you, so you can try this as well.